thank you very much, Robert. You can get your presentation up.
Okay. And just before I start, I received this the other day, which is a D-to-A converter that actually flew on the first Apollo uncrewed flight. Was that AS204 or 5? I forget.
I think it'd be 204.
Yeah, it is
204, I think.
204, yeah. So, and I received a stack of radiation incorporated modules, which are gates, which were used for testing the lunar module before they had computers to test the lunar module.
You're into collectibles then. Scott Marshall will be after you if he finds out you've got some of that type of stuff. He's always trying to collect Apollo memorabilia.
I've got 40 of these gates, and they're all sorts of different gates. I'm hoping to turn them into a working countdown timer because they all work.
Right, okay.
Anyway, enough of that.
You can share your screen. We'll just see if we've got any problems. So, as I was saying earlier, there's some feedback coming through at the moment. So, we probably try to save the questions until at the end when Robert's able to field them. So, otherwise, we might have some problems with background noise.
Okay, this will be interesting, not having any way of particularly viewing people and reactions. I've not actually had.
There's chat available, so people can still put questions in the chat.
Oh, yeah.
So while I'm speaking to you there, don't think you can't ask questions.
I haven't put the chat up.
The Audible at the moment, there's some problem with somebody's audio and it's producing feedback.
Let me see if I can put chat up as well. Okay, now I'll try and go back to share the screen.
I'm going to take my video off at the moment too because I'm still having problems.
All right, so
that's fine.
No, chat I can't see. If there are questions, let me know.
Down the bottom, Robert, there is something that says chat. Now, if you double click on that, it will pop up as a separate box.
I am looking for it. I can see everything's shifted to the top on my screen.
Okay.
And I can't see chat anymore.
It doesn't matter. I've got chat on mine for the moment. Don't panic. What we can do is we can always just take questions and you can answer them at the end. So as you think of some things, folks, just type them down and we'll get back. So don't panic. It's just at the moment, it's a little bit tricky sometimes to do this. Okay.
We've been working for a while on how we can actually launch stuff from rural Australia. Now, obviously, there are some places you probably can do it and there are launch facilities. But since I live in Sydney or Hazelbrook these days, a lot of the activities we're doing are based in central New South Wales in rural areas. So we have been looking at the opportunity. We've just started working with an area near Ivanhoe to try and piece together enough land with about 60 60 kilometres radius so that we can gather an occasional launch facility for going straight up and down, sounding rockets to space for testing purposes. And so far, so good. We have general okay from CASA, and they said that they don't mind diverting aircraft occasionally, but if it was to be a full-time space operation, that would be a lot of maybe a different level of difficulty. Okay. Okay, how do I move this thing? There we go. So Thunderstruck's involved in these areas. We've got 4 product silos, the balloon technology, which is about sending balloons fairly up into the stratosphere, as well as balloons that loiter at about 18 kilometres without propulsion. And we do a lot of work for defence and qualifying for space projects. In fact, we did one on Saturday. So we also are building stratospheric balloons with propulsion that'll live at about 18 to 20 kilometres altitude. And they can contain communications, cameras, sensors. They can patrol or stay geostationary at that altitude. Don't confuse that with orbital geostationary. This is propulsion geostationary with propellers or rotors or whatever you want to call them. The balloon will hold its vertical position, but it will need solar power to be able to have long-term capability of staying up there for initially 3 weeks, but we expect to get that up to about 6 months to 2 years if we can find the right material for that. Oops, what am I doing? Sorry about that. Learning. We're also continuing on the Mars Median mission. A lot of that's been held up because of COVID. We were meant to start gas gun testing at the Australian Defence Force Academy, but that has been held up since they shut down the academy. They're reopening it now to outside people, so we should be able to get that testing going, probably start again next year from scratch. We're also firing off rockets in the US. That also went into a little bit of a hiatus during the COVID impact over there. People wanted to stay at home, but they've sort of ventured out now with the fact that everyone's getting it, I guess, over there. And we're about to fire off rockets again. So our rockets look like that. We have a very big rocket that's about 6 meters high and 2 foot wide. It's all in US, of course. I'm trying to convert here, and I'm not doing a good job. But the picture on the left shows a Mars impactor test unit on top of a small rocket that'll take it up to about 30,000 feet. And then it detaches, the top detaches and comes down and impacts, and we make all sorts of measurements with the impacts. The rocket that he's got in his hand is for a payload, and it's the lightning bolt on it, but we're looking at probably about 50 to 60,000 feet with that one, and we same on the right, but the big one I don't have a picture of here in time. Sorry about that. But yeah, it should go to space, but straight up, straight down. In November, we launched our first rocket. Don't know if anyone knew we'd done that from this group, but yeah, that was quite spectacular and worked well. We'll be launching more and more rockets, bigger and better. That was over in the US in the Mojave site. Why won't it move? This is a bit scary. Well, we've also CATO'd because you're not trying if you don't CATO. You can actually see the rocket horizontally up there. It's turned on its side after it blew up. And there was probably a crack in the fuel. Sometimes taking these rockets out there over rough roads is not a good thing. But when you get a crack in the fuel, of course, it's burning more fuel all of a sudden and overpressurizes and bang, you're gone. Of course, when you're trying a new motor, that can also be the problem if the nozzle is too small for the rate of burn, or the grain's the wrong size, and you end up with burning more, and the pressure builds up and off she goes. We're still working on our Mars impactor technology, and now that tends to be a general impactor that we're working on. We're working with a UK company, and they have some equipment. Now, get this. They're claiming impact capability for some of their equipment to survive 34,000 G impacts. Now, that's, to me, just seems off. I don't know. It's just amazing if that's real, and we'll find out soon enough when we start doing some pretty heavy testing. But to land on Mars, we're looking at more of 500 kilometre an hour impact, and surviving that, which the G-forces will depend on what sort of springs and things we put in there to dampen things and suspension, but we don't think there's a problem. CATO, oh yes, CATO, catastrophic. Forgot about that. Catastrophic CATO. Yes.
Thanks for the answer, Kerry.
Yeah, catastrophic. Well, it not necessarily a takeoff. It can be any time in flight. So yes, we did get a little ways up before it suddenly went kaboom. Thank you. Yeah, I'll try and keep an eye on that. The gas gun testing at the Australian Defence Force Academy means that we actually fire from the left-hand side a charge along with a probe that sits inside a sort of a shield. I forget what they're called. It doesn't matter. It melts away and then it impacts into the chamber at the far end at 500 kilometers an hour. About a 6-kilogram probe will smash into 3 half barrels of Mars simulant, sand and so on. And yeah, I don't think I'm going to stand there. I don't think I trust myself to stand at that window while it was happening. In fact, they won't let you. You have to go outside. So that the cameras will take all the pictures high speed and so on. And the trick will be to work out what sort of tip, if anyone can see my picture, are they still visible too? I'll show you later, but we have the size of the tip and everything that we're using. The whole thing is the speed and all the impact data comes from the cameras and running the vision through some computing that determines what happened. What propellants are... it's a solid fuel rocket. Sorry, I should have been clear of that. There's a reason why we our rockets use solid fuel, and that's because they're going inside aircraft and we can't put liquid fuel inside aircraft. Planetary impactors, they don't have propellant, and they have to be sterile. We're working with NASA on those requirements. We have support from certain groups in NASA. We're trying to get it up to a for real, yes, the mission is on type status, but it takes a lot of work to do that. So what else? Next, that's what it looks like in reality. The tube is being pulled apart there for cleaning and adjustment, but you can see the size of the impact chamber there. And after we do the test fire into 3 half 44-gallon drums of frozen soil, it takes 2 days to clean up the drum. In fact, even though it's hitting sand in a helium environment, they still have to flush it out. There's enough oxygen around and everything that it actually starts a fire inside the chamber that gets flushed with helium. Next. Sorry, I have to click on it each time or it won't go. So yeah, that's the small impactor tester on the top of the rocket. They separate. Naturally, they're not actually held on by anything. The thrust of the rocket keeps it in one piece, and when the thrust fails and there's a bit more resistance to airflow from the rocket itself, they just separate and come down separately. The rocket has a parachute, the impactor impacts, and we can determine the height that we go to test how it will land in various types of material in the... Okay, stratospheric balloons with propulsion. We do not call them airships because CASA have a definition of an airship, and that won't be good. But we did start looking at things like this. We are looking at such at balloons that can stay at about 18 kilometers altitude. We were looking at bladders and using pumps and all sorts of things. Discarded all of that. Then we started looking at super pressure balloons, which were important. So we'd make this into a super pressure balloon. There'd be a payload bay underneath with the propellers on the side. Well, that was all very nice. The maths didn't work. So this sort of technology goes to the bin, and a lot of people are still trying to make this technology work. It's never going to work, at least unless someone can find material that's super, super light. The balloons need to be just balloons and nothing more, maybe some things. So, we're looking at all of this sort of stuff. That's pretty, but it's pretty awful. And one of the reasons it doesn't work is, you've just got all that structure to carry. and it's not an efficient use. I mean, bubbles are bubbles for a reason. They're all spherical. If they're a free bubble just floating, nice and spherical for a reason, and that is that it is conservation of energy. It's not going to be anything else but that shape if you want to actually lessen the weight of the balloon. So we're now looking at something more like this. It will be more pointed and more rounded, and it will be basically it'll have a bit of a tail as well. There's a few things we can do that has almost no additional mass, but will make the laminar flow of the air over the top much better. We may be able to put solar panels on top. I don't think so. I think the solar panels will need to go underneath the gondola there, and the gondola will look nothing like that. No space, no Star Trek style gondolas. That was our artist's view of how this would all look. In fact, other than safety around the rotors there, the propellers, we would have pretty much an open to space unit. It wouldn't have covers and things like that. And the connections to it are probably from cables coming down from the midpoint rather than trying to secure it underneath, although there may be a connection, but it won't be that big metal plate that you can see there. And this is important. I mean, we've had a look at the Zephyr technology, which is an aircraft. It couldn't be scaled up to carry heavy payloads, and the balloons can. So, but there's a little window of opportunity that we've decided will work where others have failed. So that's our next job, is in the next 2 months to actually have a balloon with propulsion being flown in the upper atmosphere. So in airspace that's not controlled, uncontrolled airspace above 60,000 feet. We'll be sitting at about best part of 20 kilometers, more like 85,000 feet. And we'll be carrying all the radar-y types of things. We have ADSB, which is the Australian standard for telling other aircraft and air services where you're located. We have all of that technology now, and you can actually see some of our balloons in flight over Australia if you know what to look for. So here's our regular balloon flights, which are just balloons. And you'll start to see why balloon technology in space have a real reason to exist. I mean, if nothing else, the Kessler syndrome is something that is important. If there's no space left because everything's exploded, well, this will be the only stuff flying. And to be able to put comms systems up that geostationary above an area are so important, and to be able to patrol seas and everything else is also important. But we can relay back to space. We can be an intermediate platform between space and Earth to, say, get over the massive attenuation caused by storm clouds, so the satellites can talk to us, and then we can relay it down. Now, regular balloon flights, you've got to say, well, what's that got to do with space? Well, here's one we prepared on Saturday. It went up on Saturday morning, and we're preparing it there, and there's some long arms that you can just see the top and bottom of the long arms going out. It was that's to stabilize the balloon from spinning, just like a ballerina puts her arms out when she's spinning. To slow down, this slows it down. We have some mass at either end of those arms. That's why they have to be double and strengthened. But that pink box is a payload of sensor cameras built by Steve Hobbs in Canberra, who is part of our team and also a major part of the Mars Society in Australia. And it's carrying 4 cameras, including 2 multispectral cameras of high definition. and it was actually underneath our payload there, the white sheet of foam on top. And we also have a whole lot of squadron flight patches in the jar for the 80th anniversary of the Air Cadets. So interesting days. We're flying multiple payloads, and this work that we're doing is also paid for by Defence, because they are also sharing in the output of the Mars mission payload. And this is sort of a primary look at the sensors that they want to go and get onto a spacecraft to orbit Mars. So there's a lot of work being done to get this all turned into a real Mars mission for a satellite. So, yeah, Steve's part of our team, but he's also part of the Air Force as Air Force Reserve. And when they realised that Steve was making sensor technology for us, they snaffled him as well. So a little bit of a conflict of interest in my books, but he's also building the same payload for them. There's a picture of the camera. A bit rough in this form because we didn't give him much time. We said, hey, got a flight coming up in 2 weeks. Get this thing ready. The pink box provides some insulation and some also from impact as well when we hit the ground. We don't hit very heavily, by the way, but it takes a lot of work to get this system, all these systems working. Probably about 2 to 3 hours of preparation, and the balloon fill is going on at the same time. That takes nearly half an hour. You can see them measuring the lift over there. The rate of climb was 4 meters per second and a bit on average. And we launched from a small town called Arthlethen, the home of the Kelpie, they tell me. And that's the payload going up. You can see the parachute getting stretched there. It doesn't open until the balloon bursts. So going, gone. Well, you think that once it's out of view, I mean, we sometimes look at this stuff about 8 to 12 kilometers up, you can still see the balloon. This was a bit different. We actually saw the balloon, and you can see the little hazy picture. We spotted it from this small town, and it was 29.5 kilometers altitude. We then watched it very carefully using the edge of a roof as a guide to be able to keep tracking. And then, of course, we then watched it burst at 34.5 kilometers altitude. And you've got to realize it was also diagonally away, so it was probably closer to 50 kilometers through the atmosphere. And you could see that white spot. And when it exploded, all you could see was it vanished. And of course, we recover the payload, and it landed nicely in a wheat field, which also cushioned the impact. Okay, I'm going to stop there. I have a second presentation, but does anyone have any questions?
Yeah, I've just got a quick question. Robert, you can actually track that. So what are you using to track the payload for? Because obviously you recovered it.
We're doing some amazing things. One of our guys builds the tracking technology on very tiny surface mount devices. We get them built professionally, and we're turning them into a commercial project. They report every 40 seconds. We also carry a spot tracker and a gimbal, so it's always pointing up towards space. So that sort of technology is pretty simple. The next one is when we fly the ADS-B systems. They're tiny. I mean, because they only transmit 250 watts at 250 watts of power for 8 milliseconds. The things fit in the palm of my hand. It's tiny with some antennas we put up, and the whole thing just uses virtually no power. I mean, it's an average of 2 watts of power with a slight increase to 4 watts during the transmission. So it must have some capacitors in there as well. But the whole thing only weighs 100 grams plus the battery. And the next thing is we're also using UAV technology. So we have 4 tracking systems at times on board these units, and we can't help but find it. We're also now making them in a waterproof container for the tracking, so that if it lands in a lake, we'll still be able to hear it and recover it from the lake, because quite often it's the memory storage units that are the mission critical part of the flight, not the actual recovery of any components, which may be only used once anyway. We actually have a very highfalutin contract with the Air Force with Plan Jericho for pointy end of the stick stuff. They've got us pegged in as a secret weapon for the what's it called? The defense fight with the USA that's coming up mid next year. Talisman Sabre 2021. We're their secret weapon because we'll be flying sensor technology over the top of the battlefield. Okay, so any other questions there?
Robert?
How long have I got?
It's John Strang here.
Yes.
What's the purpose of sounding rockets, and are the balloons filled with helium? And what do they actually achieve?
Well, the purpose of the sounding rockets are to take technology up into an area where it's sort of weightless, if you want to call it that, microgravity for anything up to 4 minutes before it returns. So you can do a lot with experiments in that time period before it then returns to essentially starting to get friction from the air and slowing down. You can also use that sort of sounding rocket technology to develop your own orbital technology. I didn't put a lot of orbital stuff up here, but that's the next bit I'm just about to show you. Have we got time to go on to the next one? We use helium, by the way, and we've had yogurt companies like Bully Yogurt freeze yogurt in the clouds, seriously, as part of an advertising campaign. We've flown post-it notes for super sticky post-it notes to see if they'd fall off while it was hammering back towards Earth at some hundreds of kilometers an hour and so on. I mean, MYOB was doing computing in the stratosphere as part of their internal promotion, and they wanted us to make it look like we were doing a space launch with all of this at a mission control. We use it. It's used for advertising, but it's also used for communications. Our next flight will be testing some Defence Force communications at altitude, and they want us to sort of loiter, if I can say that. We, hover at about 18 kilometers for a while. We might go up slowly, we might come down slowly, but we'll be stationary sort of for a short period of time, because the wind in the tropopause that sits between the troposphere and the stratosphere is very quiet. On this weekend, it was down to 6 kilometers an hour. So you don't go too far. The angle in the sky is pretty much the same. So we can do all sorts of tests. We can look at the sensor technology, spot cars, vehicles, water, how healthy plant life is, all with these multispectral cameras. So depending on what you look at, you get a whole range of different things. Now, obviously Mars, we're not going to be looking for vegetation, but we will be looking for water. We will be looking for a whole lot of things with these cameras. And I'm sure lots of people have done this in the past with stuff for Mars, but Australia doing it is important.
Okay. Thank you very much.
All right, how much time have I got left?
No, you've got enough time. I think you've got till 9 o'clock, Robert. No problem. So if you can go that long, that's
don't tempt me here.
That's all right. Half an hour will be fine.
All right, let's have a look more at what's happening in central New South Wales. See the lovely word, space and cargo facility. Well, that's nice. We're actually building a hangar in West Wyalong right now at the airport, and it's being built for us by the council, and we will be working from there as a joint partnership with the council to build our stratospheric balloons with propulsion. I've got to get a better name for that. Like I said, we don't want to confuse it with an airship, which has a specific set of rules within CASA. We don't want to get stuck with those rules, or our poor pilots will be trying to line up on a runway or something silly, which is true. They told us we needed to have instrument rating for landing, for instrument rating to fly the balloon. And we said, seriously, name one thing that we need instrument rating for the balloons that we're flying. And they couldn't come up with a single one, so they're rethinking it. Okay, we all know the global space boom is amazing, and I've noticed that it's no longer 440 billion spend in this per annum. It's gone up, hasn't it? Is that right? Can anyone confirm that it's now a lot higher?
No, but I don't know what the figure is. So,
sorry,
I think it's higher than that now.
Yeah, it's climbed. So it is climbing. Anyway, we were only at 4.4 billion of that.
You're not sharing your screen, by the way. Somebody.
Oh, sorry. No wonder it didn't. Okay, sorry. Pardon me.
Yeah, I wasn't sure what you were doing there for a second, but you're
right.
Yeah,
well, that's right. I'm not sure what I was doing either. All right, let me get back to sharing a screen. I forgot I had to reshare it after.
Well, you changed presentation, so I'm assuming it's a different presentation.
Yeah, that's right. Let me just make sure that's back up. Is that full screen again?
Yep.
Okay, so okay, we're straight into this. So we're looking at being able to launch payloads of 250 kilograms. It's possible even to get a small payload to orbit with what we're trying to do. Space tourism could be a big driver with what this is, and spaceports will be needed. And what we're looking at is not building a spaceport, but a spaceport may come from what we're doing. So we're coming from a different direction, which does not require a ton of money. And that's where spaceports tend to fail. People spend a lot of money and then no one wants to use them. Well, if you come the other direction, it doesn't lose money. All right, we're an aerospace company, etc. We've got a couple of astronauts working with us. We've got Rick Armstrong, Neil Armstrong's son, providing support, and he's providing some of the funding for the Mars mission. We have Jerry Ross, who's done 7 flights to space, mainly to build the International Space Station, and Nicole Stott, who's a more recent astronaut. She's certainly very vocal in helping us get the things underway that we want. We've got a lot of other people involved, and people here in Australia. You can look it up on the About page from Thunderstruck.space. We're partnering with Defence, and we're also looking at providing rockets for Defence in the future for testing purposes initially, but hopefully for longer term facilities. So that's on the cards to be able to fly rockets for Defence. We're working towards that because all of our rocket building is in the US at the moment. We've got to come out here and do it, which requires some careful ITAR sort of toing and froing, but it'll happen. So we've got Lightning rockets, but we're actually looking not only at doing some sounding rockets around Ivanhoe area, but we're also looking at sea launch but not sea launch from the water, but sea launch from the air. So it's an air launch over the ocean, I should have said. And as far as the space agency concerned, there is no launch facility license fees required. And it's from what we can see, it's the lowest cost launch system to LEO. We can launch off the East Coast, so we fly from our rural Australian routes out over to the ocean, past any shipping and launch. So our risk is very, very low. We can also fly up to the equator and launch as well. So we have been looking at an unmodified Hercules, a J130, but unfortunately, there's no flight profile to be able to drop something of this size out the back of a J130. So that now is probably off the books. We know that the C-17s that the Defence Force have, certainly they're the big cargo things that often go down to Antarctica with a lot of cargo. The Hercules do as well, but they need to have in-flight refueling to be able to make that trip, I believe. But the C-17s, and you'll see a picture of that in a moment, they're bigger, and they also are not propeller driven, so they can get a higher altitude. But the new Embraer aircraft, I think they were KC-390. Now they're just the C-390. They've changed their designation because they wanted people not to think of them as more, well, they thought it was more versatile with the cargo rating. So we can drop a rocket from 10 kilometers out the back. We should be able to get 250 kilograms then to LEO by igniting it at about 8 to 9 kilometers altitude. It'll still be flying. It won't be just falling, but it'll be gliding. We will put out some canards the moment it ejects from the aircraft, so that we can then angle the front up to the right degrees, somewhere in the low 30s, to then ignite this thing and have it fly off. And if you're not launching very regularly, you can get income for the aircraft by having it actually do cargo work in between flights. So in the early days, you don't have to have an aircraft just sitting there losing money. That's the C-17 with a dummy rocket going in. Dummy rocket's also the correct weight, and it's much bigger than any rocket that I'm thinking of using here in Australia. It slides in. There's a whole lot of wheels that go around. You can see the wheels there. So when it rolls out on a cushion of wheels underneath and either side. It's a very neat system, and there it is there, falling out. So the drogue chute pulls it out and then flips off while the rocket then moves away. The aircraft can bank away as well, and once they're far enough apart, the ignition takes place. So that's what we're basing this whole thing on. We're working with the Air Force at the moment. No one has an appetite to do this with a C-17, but we do have the Embraer company wanting to show that this can be done. So we're looking to be able to work with them and do some test flights over in Brazil. So that's on the cards. It all costs money though. So there's nothing around on the East Coast, and no one can build anything on the East Coast for launching, I believe. I'd like to hear otherwise. I mean, most of these locations need enough room so that a big rocket won't turn people into jelly from the sound alone. They have, if they're liquid fuel, you've got expensive ground launch facilities. If you go to remote areas to get the land you need, you have real problems with expensive logistics, poor logistics, and you've got to pay your staff a lot of money to work in a remote place. And you also get very bad weather near the equator for a lot of the year. So what do we need? 2 kilometres steel runway with lights, taxiway. A hangar would be preferable to leaving it outside. Rocket fueling, vehicle assembly building, and to make sure it's above the flood zone. We actually have been looking at a lot of land around the area, and you'll see a map of one of the places we looked at. That's the Embraer, and it's an aircraft that look, it depends on the price, but let's just say 80 million for the aircraft, but then you've got it for forever, and because it's unmodified, it's easily sellable again should anything go wrong. And that's the cockpit, which then behind the pilots, it just opens up into the whole cargo area with a standard cargo layout facility on the floor. We don't change anything to be able to do this, so it's a standard cargo aircraft when it hasn't got a rocket in its belly. That's what it looks like. You've got certain restrictions when you fly these things. The main thing is that as it pulls out, you can't let the rocket hit anything by having it pull out too slow or too fast and so on. But the rocket is about 20 tons, I think. I'll have to go look it all up. It's too long since I did the work on it. That was November 2019, our first rocket launch. Very spectacular. Just amazing to see that go up for the first time. The first one didn't KTO, so that was a good thing. So we're looking at providing all of those things. So if I provide these slides, you can have a look at this sort of thing in the future. But there's the people that are involved, the major people. We will look at Jenny Radenbauer is a very well-known planetary scientist, very much involved with Cassini. And if you had a look at the ABC Catalyst show, she was on there, one of the 4 planetary scientists discussing what was found. Okay, so we are in negotiation with some launch providers. It's early days. I'm not trying to make out that we're doing big, wonderful things here. Virgin Orbital has had a bit of an expression of interest, but they tend to want a lot of money from the government to be able to say, come here, because it's cheaper for them to launch in the US. So they'd want people to be paying them extra to look after the costs. Virgin Orbital is the orbital company launching rockets into space, not the company that does the joyrides to space. We're also working with a Canberra UAV operator, because when these things aren't being used, the runways and everything, we can use them for all sorts of things. Anyone see Top Gear? Well, you'd have noticed that in the background of the airport that they're racing around, there's usually a 747 cargo plane. So all of a sudden, our little joint facility, we can look after cargo, it can look after all sorts of space flights, and the income stream starts to grow with other customers. It's a bit like, you go to Queen Street in Woollahra and there's a ton of antique shops there in Sydney. And they're all there, and they don't actually cause each other a problem. They actually make more money by them being all in one place. So if we can get other people to come to our airfield because it's ideal and it works and everything else, then it makes money. And for the operator of the airfield, which hopefully would be us, and that means that this airfield is actually making money, not losing money. And you're starting to see the whole thing develop into a workable space center without actually building a space center. It sort of grows with you. This was based on an early figures of using the Hercules, the Stretch Hercules, the J130. The cost of the year one with an Embraer would be much higher, but it actually doesn't change the figures on the right-hand side too much. So, thinking of it in that way, there is certainly a lot of profit to be made just launching only 20 rockets per year. The interesting part of this is that we could actually launch a rocket a day if the customers were there, because once that aircraft comes back, it's empty, pull out the roller and load the next one in and off you go again. There is actually no requirement for cleaning and so on, because it's not like a regular launch pad that has to be checked and cleaned after every flight. You probably, to take weeks after each flight to be able to get a regular launch pad that is launching stuff to orbit checked and certified for use. This is not the same. Sure, it's an aircraft. It has this. All it needs to do is go through its regular aircraft checks. Maybe an extra little bit of work with because we are dropping it out the back, but nonetheless, very minor situation there. So we talk about triple play because you've got cargo, you've got multiple people using it, and you've got the possibility of having this thing as a space facility for multiple people to even land aircraft there, land spacecraft there. The trick is where they can take off again from. Not too far away, actually, a short hop and a jump. But it's certainly a facility that could be of some significant use. So we're looking at, you can read all that later, inland freight. We're looking at the new inland train, the inland train that goes through that area near Temora. We've got a fair bit of opportunity as well to buy land at the right price. That's where we were looking at, just halfway between Temora and Cootamundra. And there's a nice bit of land there that's flat above the floodplain, and certainly it's actually that shape. The interesting part about it is that it's very close to the intended inland rail junction. So that's now more of a reality than it was even before. And being 6 kilometres away, it means that for a cargo airport, this makes a lot of sense to then also be a hub for the inland rail train that goes between Melbourne and Brisbane, and many stops in between. So, the cargo benefits are immense, but you can read all that later if you're interested. Local tourism flights may be possible. I think we're just a bit too far away at Ivanhoe, but I'm not the operator. I don't know the glide rates or anything else, but certainly there may be other places we can launch from. I've only just started looking at the easy places to actually get a license to fly from. So there's other styles of space flight, as I said, sounding rockets. There's to land one of these larger craft, we would need a 4-kilometre runway, so it needs to be a bit bigger. The creation of a high-tech village and so on. There's a lot of opportunity here to do more slowly. It would actually be more of a systemic growth, provided it is organised well. Other opportunities are university-type campus firefighting. We've had defence saying they'd use it as well. Why not? If you've got a 4-kilometre runway, defence would want to be able to use it from time to time. So anyway, what else? of course, the benefits for the locals are huge. This sort of thing in inland Australia is going to create high-tech jobs where high-tech doesn't exist at all. And that's why we're partnering with the Blandshire at West Wyalong, because simply they see this as a way of getting some high-tech stuff going in there, even for a small number of people. If this becomes a hub for launching our stratospheric balloons with propulsion, then they're in a very good position, and that's why they want us in there. It could be quite significant to be running a fleet of these stratospheric balloons based from there. And of course, you only need a couple of pilots on duty at any time to possibly look after about 20 of these balloons. We've had interest from the New South Wales Government Radio Network, which looks after police, fire brigade, ambulance, and others. And they are saying, if they have a failure, can we fly one of these things over the top and provide the government radio network relay down to the ground while they repair the local area? Well, yes, we can. There's a lot we can do. We can look after areas for illegal fishing. We can look after people who are illegally coming into the country via the sea. We can look after erosion. Well, not look after it, but find it. Erosion on the beaches. We can look at pollution, you name it, farm health. There's so many things that this technology will do with balloons, but also having the rocket technology there, it all grows together. It's not just one area that we're looking at. We'll be able to service many parts of what we're building here in this area, the centre of New South Wales. So anyway, we've got...
Sorry, I couldn't quite hear you.
My
Could
phone,
you please repeat what you said?
my phone decided that I was talking to it. My apologies. So there's a few...
I seem to be having trouble hearing you.
Go away.
Sorry about that.
Let me turn the volume off. Okay, so there's a few summary items, more summary items. The federal government is stepping in. We appear to have a fair bit of funding heading our way, and some of the funding will be not just, it could be in the millions of dollars shortly, so it adds up. We haven't got interest from overseas. The moment we, pardon me, fly an airship in the stratosphere that's able to hold position, the world's going to beat its pathway to our door, because it's never been done before, and we think we know why. Anyway, that's the talk for tonight. Thank you very much. So back to normal. Oh, there's a lot of questions here that I haven't been looking at. Okay. Yep. There's something here about fairings falling back into the Pacific. The Pacific, it's a long way away. Well, lots of people are dropping fairings into the Pacific. They're rather minor, but, there will be questions asked, I'm sure. So it depends what you make them out of, whether they are going to contaminate anything and whether they will quickly disappear. Depends what you make them out of. So I assume that not many people are able to catch them, and I know that even SpaceX don't catch them all. So I guess that bridge has already been crossed. But I think if we can make this out of something that pretty much dissolves and doesn't cause a problem, then we're better off. All right, so let's have a look here. What else is there? Tricking up done to engines for the film. Oh, right.
We're trying to work out where Ivanhoe is exactly, Robert. I think that's what the last bit was you mentioned.
Okay. Northwest by a couple of 100 kilometres of West Wyalong. It's... Anyone got Google Maps? It could be within the glide limits of, say, Virgin Galactic. I don't know what their glide limits are, but probably not. but certainly if they were, Ivanhoe just has so much empty land up there. It means that you can just talk to a couple of ranch owners, and they'll put together an area big enough to actually fly in one hit very easily, as well as Crown land. There's just nothing out there. And then it's a matter of posting your flight days and so on. If people take the risk, provided they're not in great numbers, then it doesn't, the risk becomes theirs. The chances of being hit by something are so minute if you're near the outer edges. Ian was telling me about this many years ago. Ian Bryce, thank you very much for cluing me up years ago on all of the risk and things falling back to Earth. Yeah, very interesting stuff to have to consider. But it's well and truly an area with virtually no one in it. I think there's an opal field up that way too. Yeah, an opal town. But anyway, White Cliffs. Yeah. Anyone know where that is? No, probably not. Oh dear. Anyway, you can look it up afterwards. But we're looking down more of the southern part of the state for most of our operations.
So you're looking at closest to Mora by the look of it, down near Kootamari.
Oh, that was one site. It's strategically very good there because there's water that's artesian water, which means that droughts won't stop you flying because you will have water in your tanks. You wouldn't fill it up; it'd be trickle charging the tanks to start with. But if you're launching out of the back of an aircraft, you're not using a ton of water like they would use on a very large rocket flight. So you don't use your water. It means that you're not putting a drain on the local area.